Okay, so yeah, elements are arranged by increasing atomic number. So if you guys look to the side over here, what's the atomic number of hydrogen? 1. What's the atomic number of helium? 2. What's the atomic number of lithium? 3. What about beryllium? 4. Boron is 5. 6 is carbon. So they go 1 all the way up to 118. It's not there yet because this is made a long time ago. That just reminded me, we should have another quiz this week.
No.
So last week we had what? Groups 1, 2, 17, 18, right?
Yeah, let's not have it anymore.
So I think Friday sounds like a good day. We're right here, 13 through 16.
Oh,
Oh
dang.
my gosh.
So why don't you guys take the other sheet out with the circled elements? Let me go through those quick, then we'll come back to the notes.
My brain.
So I'll write that down. We got a current event as usual, and then also Friday 9/29 quiz on groups 13 through 16. That'll be Friday. And I won't be here Friday in the morning, so you guys will be taking that without me being here. You can handle that. That's fine. So 13 through 16. Go to that sheet with the circled elements. 13 through 16. If you don't have it, then you just have to look to the side as I point at it. But I believe all of them are circled except I, N, and TL. So I think in group 13 right here, 49 and 50 and 81, these two are not circled. You need to know all the other ones. So let's go through those right now. But some of you are not with me here. Why are you doing that right now? I mean, I know why you're doing it, but please don't do that right now.
Sure.
You need a circle sheet? Okay, good. Moose, you got it. John, you got it? I feel like you're pretty organized, but have trouble finding stuff. Would that be accurate?
Yeah, it's accurate.
All right.
Don't forget you have your folder, John.
Yeah, if you keep it in the...
I'm pretty sure
Yeah, I got
it's
it.
in the folder.
All right, nice. Coming through. All right, so I don't really need you to look over here. All right, I'll just go through. Let's go through group 13. I'll say the symbol, you say the name out loud. It helps you kind of start to learn it, learn how to say it. So group 13, B. Boron, thanks, man. Everybody, B. Boron, thank you. AL. Aluminum, Nate, let me. Okay, AL is aluminum. GA. Gallium, right. And that's it for group 13. Group 14, C. Carbon, Declan, you with me?
Yeah.
Okay, C is carbon, SI. Silicon, GE. Germanium. Jordan, you with me? Yeah. Okay. You guys don't need to yell them, but I just want you to say them, all right? SN. Tin. That one's a little bit weird, right? A lot of these symbols are based on Latin terms, so SN, I believe it's stanus or stanum was the Latin term for tin. That's why it's SN. What about PB? Lead. So plumbum or plumbus, that was lead in Latin, so that's why it's PB. N. Nitrogen. P. Phosphorus. AS. Arsenic. SB. Antimony or antimony. Either one. Bi. Bismuth. O. Oxygen. Come on, why don't you guys say it together? S. Sulfur. Se. Selenium. Some people say selenium. I say selenium. Te. Tellurium. And then Po. One more time, everybody. Po. Polonium. Good. So that's the ones you need to know for Friday. All right? So you already did 1, 2, 17, 18. Now we're doing 13 through 16. All right? So it just reminded me. That's why I took a little pause from the notes there. All right. So back up here. Elements are arranged by increasing atomic number. So we're going to get to these in a second. What does that number tell us?
The amount of electrons.
You were right the first time. Protons. So let's write this down. The atomic number is equal to the number of protons. What the heck is a proton?
Negatively charged.
Let's go to table O, as in octopus.
Where?
Go to your reference table. They start with table A, then go B. Moose, put that away.
Oh.
This is your reference tables. It says reference tables right on top. Go to table O, please. You're learning how to use the reference tables too, right? So, go to table O. They're in order. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O.
P.
Sound like talking to my daughter here. Maybe I'm just in that mode. You guys, of course, know the alphabet. All right, you're on O. Alex, why do I have you guys go to table O right now? Good. Protons, neutrons are on there. What else is on there? Positron. What else? Gamma. Gamma. What else? Beta. Right. Beta particles. And then did someone say alpha?
Yeah.
Yeah. So that's all of them, right? You got alpha, beta, gamma, proton, neutron, positron. Is that it? Okay. Now, what is a proton? You said negatively charged. So look at table O, Nate, and change your answer.
Positive charge.
Well, all right, you guys are all Nate, I
Wait.
guess.
Which one's negatively charged?
That's where we're headed with this. So protons, okay? Proton, the symbol or the notation on table O is what? What's the notation?
B.
Not the symbol. Under the column it says notation.
1/1H.
1 over 1H. Everybody write that down. 1 over 1H. That's a proton. Okay? What is a proton?
Positively charged ion.
It's a positively charged, it's called subatomic particle, little tiny particle. John, do you know what everything is made up of? That's why you can't trust them. They make everything up.
No.
Atoms. Get it, Ben? Make everything up. Can't trust them. So, atoms make up everything. So, the surface of this desk probably has trillions times trillions times trillions of atoms on the surface of this desk. Okay? So, what makes up atoms are protons, neutrons, and electrons. And that's what makes everything up. So, these are kind of a big deal. So, that blue number over there is the atomic number, which tells us how many protons all of those elements have, and all those atoms of those elements. So this is kind of a really big deal, important thing for you to remember. So that's what a proton is. Little tiny particles we're all made of. Okay? So protons. Did you raise your hand? Okay. So protons on table O, this here, this number, that means it's positive 1. Positive 1. That's what that number means. This number here is the mass. So proton has a mass of 1, and its charge, right? This number is the charge, positive 1. So I could say that's the charge of it. Okay, so that's really messy. That's the charge. So protons are positive with a mass of 1. Okay, so the charge is the bottom number, mass is on top. So protons are kind of a big deal. All right, on table O, Moose, which particle has a negative 1 on the bottom?
-1?
Yep. Go to table O. I think it's the only particle, the only notation that has a negative 1 on it.
Oh, beta.
Beta, right. And no one write this, just watch. Isn't it 1 or 0 negative 1 E
Yeah.
under notation? Okay. Does anyone know what that is?
Electrons.
Yeah, so beta and electrons mean the same thing. I hate that it's not written in there. Do not write it in there. Okay? But it should say electron. That's an electron. All your atoms in your body are made up of protons and electrons and neutrons, but those are negative. Electrons are negative. So I'm just kind of starting the conversation of learning that stuff. We'll come back to that. Anyways, back to the periodic table. Atomic number. What's this word mean right here, Jordan? You said, what'd you just say? Going up, right. So again, we start at 1 and go all the way up to 118. So that's important to remember. What is it not arranged by? I've made a point of this a few times now. What does not increase all the time? Mass. Look over here. One more time, I'm pointing it out. John, you with me? T, E, and I goes down, right? For reason that does not go up, so that the mass number does not always go up, but the atomic number does. Okay, so that's the kind of basic gist of the periodic table. Now let's talk about some other things. What else do you know you learned from the video? Oh, the bookwork. And I think we didn't go over did we go over the other page, 24 through 28? Or 24 through 31, I mean? I think we did, didn't we?
Yeah.
You remember? I don't think we went over
did.
24.
I don't think we actually went over it.
It's all right. We'll get to that. Yeah, I don't think we did. We'll get to that. All right, anyways, what else from the video? Remember, what'd you learn? Mendeleev organized it. Good. What else did we learn? No, Russian.
The gaps for discoveries.
Gaps for discoveries.
I'm on a roll, guys.
You are. What are most of those elements up there? Declan, you see that big sheet of copper behind you?
Yeah.
Can you stand up and hold that up to everybody? Don't cut yourself, please. All right. So most elements, can you pick up what you knocked on the ground? So most elements are like that piece of copper. Solids, good. What else?
Metal.
Metals. There's 3 types of elements. Most of them are metals. So 3 types of elements.
Oh, yeah.
Most of them are metals. And where are the metals up there?
They're like all on the left.
Right. Metals. Left of what?
The staircase.
Staircase. Left of staircase. Most of them up there are metals. I'll explain in a second. All right, what are the other types of elements?
Gases.
Non-metals, right, so gases. Non-metals, good. They are to the right of the staircase. And what's left? Metalloids. Metalloids. And they are on, or you know what? Come right on. Right, touching the staircase. Touching the staircase. Jeez. Touching staircase. All right, I'm going to give you a list of all the metalloids. Here we go. So here's the metalloids. You got B, Si, Ge, As, Sb, Te, and Po. Should be 8. 1, 2, 3, 4, 5, 6, 7. What am I missing? What did I miss? Oh, At.
Why isn't
Al.
Al?
So Al is not a metalloid. This is Al. Yeah, it's aluminum. This is aluminum. And it is? Metal. Aluminum is metal. Okay? So aluminum, if you look over to the side, aluminum is not a metalloid. So look over here, please. Here's your staircase. Everybody look over here. I'm trying to help you understand this. At, Po, Te, Sb, As, Ge, Si, and B. All of them are touching the staircase. This is the only exception. Al is touching the staircase, but it is not a metalloid, it's a metal.
Why isn't there a gap there then?
So, what do you mean a gap?
Because don't they just put the gaps there for like...
There's no gaps. There's no gaps anywhere.
There could be a gap. Is what I'm saying.
Why, yeah, I'm asking why. Why would there be a gap?
Because it's not a metal or it's not a metal.
Right. So, remember what Mendeleev... No, it's a good question. Stop your nonsense. Pay attention. Why are they where they are? Why does this even exist? Atomic number, but what did Mendeleev say? Because they're similar. They have similar properties. So aluminum, silicon, aluminum, boron, aluminum, gallium, they have similar properties, so they are near each other. But it's different enough where it's not considered a metalloid. So it has to be where it is because of the properties. It's hard to teach it all right now in 30 seconds, but that's why it has to be there. Okay, so metals on the left, non-metals on the right, metalloids touching the staircase. Your homework is just simply identifying these. All right, very simple. I'll give it to you in a little bit. When are we out of here? 16? All right, yeah, we're gonna stop here in a minute, showing you a demonstration here. Let's talk about the properties of metals and nonmetals. Okay, so properties. We got metals over here. We got nonmetals over here. I think you learned them in the video and then in the book work too. So go for it. What do you got? Give me a property of pieces of metal.
Metals are shiny.
Shiny. They have luster. Good job. What about nonmetals?
Not
shiny.
Give me a word for that.
Dull.
Dull. Very good. Declan, stand up again. Pick up that piece of copper. Hold it up for everybody again. Okay, so you see it's shiny. Can you bend it?
Yeah.
Okay, very good. Sit down. Thanks.
Okay.
You're a good assistant. All right. Malleable, right. It can bend. Malleable. Underline that. Let's define that. It means you can bend metal. Can bend it into shapes. Technically, it means flatten into sheets. Look up the word malleable. Somewhere on the internet it'll say flatten into sheets. But that's too specific for me, so I just say that. You can bend it into shapes. You can do this with metal too. This is copper wire. So you can make wire out of it. What's that called? I think I told you the other day. Maybe not. Quack, quack.
Oh, duck something.
Ductile. Ductile. Form into wires. What about nonmetals? What is a nonmetal?
Rocks.
Rocks. Good. This is actually a bunch of coal.
It's carbon.
Yeah, it's carbon. So if I took these little, here. I don't know the last time this thing was opened was like 35 years ago. So if you see that there, I just want you to kind of get a visual. All right, so take a look at the coal here. Just getting ready for Christmas and Declan's present. I got plenty to go around for the rest of you, actually. If I don't give it all to him. All right, anyways. So, if I hit this with a hammer, what do you think will happen?
Crushed.
So would it bend?
No.
No. It crumbled.
So we think it would just like kind of turn into like, I mean, these would probably just explode, right? If I just hit it with a hammer. Okay, so this carbon over here, number 16, group 14, to the right, it's a non-metal. So if I hit it with a hammer, it will not bend. What will it do? Crumble, break, right? Shatter. So, what's that?
Metal can do that. It's hard.
Not really. You're never going to hit a metal with a hammer and it's going to just shatter.
I mean, if it's like hardened steel, you can whack
It might crack, but I don't know about shatter. I mean, if you can prove me wrong, find the video. So non-metals are brittle. You know, and there's always exceptions, Nate, always. But so in general, these are the properties, right? Because Nate's right. If you get a metal hard enough, heating it, certain alloys, they can crack and break. But in general, these are the properties. All right, anyways, what else do you know? And then I'm going to show you some of these properties. What else? You guys ever eat? Sure you do.
Oh, you can
You ever cook?
It's edible.
Who cooks?
TV.
I cook.
What do you cook?
Pizza rolls.
What?
Hamburgers.
You cook hamburgers?
Pasta.
Where? Where do you cook those things?
On my stove.
On your
Oh,
stove.
it's conductive.
So you just take a hunk of meat and throw it on your stove?
No.
Explain.
It's conductive.
pan.
Okay, the pan.
Pan. What's the pan made of?
Milk.
Right. So it
Pizza.
Heats.
Conduct.
conducts heat. Right. Metals conduct. Oops. What am I trying to do? Conducts heat
And electricity.
and electricity. Very good. Conducts heat and electricity.
Well, some gases can fix.
Yeah, but again, these are the general properties. There's always exceptions to things. So, nonmetals do not conduct anything. What do you call something that doesn't conduct? Starts with an I.
Insulated.
Insulator. Very good. Now, before I forget, let me give you your homework. Then we're gonna go back and play with something that you guys are really gonna enjoy. Let's kill that.